Hello, everyone. In this video, we're going to look at the 2.3, 2.4 notes on the product and quotient rules. So just to recall where we are at this point in our class is we are learning shortcut formulas for computing derivatives. So in our previous section, we looked at power functions, so functions like x to the n, and how to compute derivatives of those functions. We also looked at sums and differences of functions. So now the next step naturally leads to computing the derivative of product of functions and a quotient of functions. So let's get into it now. So first, we're going to look at the formula for the derivative of a product of two functions. Now, when you start looking at this, you might think that the derivative of this product is equal to, well, the derivative of f times the derivative of g, or f prime times g prime. But the formula for computing this derivative is actually a little bit more involved. So I'll write it down now. So the derivative of f times g is going to be f prime times g plus f times g prime. So one way to think of that is derivative of that first function times the second function plus the derivative of the second function times the first function. So kind of each function gets its turn to be the derivative and to be the original function. So this is often called the product rule. So why is this the formula for a product of two functions, or the derivative of a product of two functions? Well, in order to show why this is true, we'd have to go back to the limit definition of the derivative. We'd have to use that definition with a generic f times g function to compute the derivative, and this is the formula we would end up with. If you'd like to see how that's done, you can look in our textbook. You can also Google something like proof of the product rule, and you will see, you can probably find a video or some other resources how it's done. I'm also happy to answer any questions about it. But for us, we are concerned about using this rule, and how we use it is as is written here. And we'll see some examples. All right, so now let's get to the quotient rule. So when we want to compute the derivative of a quotient of two functions, meaning a function divided by another function, we have to follow the following rule. So this one's a little more involved, but I'll get into some helpful ways of remembering this formula. So how we write the derivative here is the following. So we take g of x times f prime of x. So the denominator function times derivative of the top minus the numerator function f times the derivative of the denominator all over g of x squared. Okay, so let's think about how on earth we're going to remember this. So one thing I can call or label the top function high, like the high function, not that kind of high, but high above the other function. And then the bottom function, the low function. And why I'm doing this is because by labeling the functions high and low, we can think of a cute little rhyme for remembering this formula. So then if I were to write out what this formula is, well, this function here would be low. This would be the derivative of the high function minus the high function times derivative of the low function all over the low function squared. So what we can say is low d high minus high d low over low low, or low squared, but I like saying low low better. So again, that's low d high to the bottom function times derivative of the high function minus high d low, high function over derivative of low function over low low, the low function times the low function. So this, it's a little funny of a rhyme, but it can help us remember. This, as you might guess, is called the quotient rule. It's the rule that tells us how to take the derivative of a quotient or a fraction of two functions. So please pause the video at this point, go over these two rules just to get some familiarity with how they're written. And then when you're ready, we'll go over example 1 to help make this rule a bit more concrete. All right, so now let's take a look together at example 1. So example 1, we're asked to compute the derivative of x squared times x cubed. So we can see this as a product of two functions, x squared times x cubed. So here, our first function, f of x, would be x squared. Our second function, g of x, is x cubed. So now the product rule tells us that the derivative of x squared times x cubed is equal to, and we can even have it up here so we see it, x squared prime, or the derivative of x squared. So I'll write d of, or d by dx of x squared times x cubed plus x squared times d by dx of x cubed. So we see that derivative plays with each function, and then we take the sum. So let's compute the derivative of each part here. So the derivative of x squared we saw would just be 2x using that power rule. And the derivative of x cubed would be 3x squared. So now putting all this together, we have 2, and maybe I'll use some color coding here. We have 2x times x cubed plus x squared times 3x squared. So now we can multiply our terms together. So we get 2 times x to the 4th just by combining those exponents. We have the same base x, so we add the exponents there. Plus, now we can put our constant in front, 3. X squared times x squared is x to the 4th. Now what do we notice about these two terms? They each have an x to the 4th. So we have like terms. So we can add the constants, meaning we factor out an x to the 4th from each term. So we're left with 2 plus 3. So this becomes 2 plus 3, which is 5 times x to the 4th. So our derivative is, all right, here, derivative of x squared times x cubed is equal to 5 times x to the 4th. So one thing I want us to pause and think about here is that there is another way we could have computed this derivative, and maybe you saw it right away. So what we have is a product of two functions, but we can multiply these two functions, x squared times x cubed, together to simplify our function. So I'm going to say, but also x squared times x cubed is equal to x to the 5th. We just use exponent rules and add those powers together. So then what we're computing here is also derivative with respect to x of x to the 5th. And what is that using the power rule? The 5 comes down, we subtract 1 from the exponent, so we get 5x to the 4th. Notice that's the same derivative we were getting using the product rule. Not surprising, we should be getting the same derivative no matter which direction we take. So this is all to say also that sometimes it's really tempting to see a product and think, oh, use the product rule. But sometimes it is simpler to combine terms and use a simpler rule like the power rule. But this product rule will come into handy with more complicated functions like we'll see in the next example.